Okay, Jyoti, can you hear me now? Okay, sorry. So starting again. So we are starting with the coupled reaction. This was one simple topic which was left. Now here there is reaction 1. This reaction is non-spontaneous. You can see delta G is positive. Delta G positive means non-spontaneous reaction, means reaction cannot take place. Whatever you do, reaction cannot take place. But the second reaction, you can see that it is negative, is spontaneous. Now I want to carry out this reaction, but reaction is non-spontaneous. So what we can do, we can carry out both the reactions together. Now you carry out this reaction. Check. See, you add these two reactions. So treat this Cu2 as with sulfur and with O2. It will give you 2Cu plus S plus SO2. Use Hess's law. This is delta G1, this is delta G2. So what is delta G for the overall reaction? For the overall reaction, what is delta G? Mhm. Plus 86.2 minus 300.4. And this answer is negative. So it means this reaction is spontaneous. It means I can convert Cu2S to Cu by using the other reaction also. Second one. One reaction has a positive delta G value, other reaction has a negative. So when you combine these two reactions, if the overall delta G is negative, reaction is spontaneous. Sammy, is it clear? So this one topic was left. You know, in our biological system, if A to B, if delta G is positive, let's say this is a biological reaction, a reaction which is happening in our body, and if delta G is positive, then this reaction cannot take place. But reactions are happening, they are taking place. Why? Because they are coupled with ATP. ATP acts like an energy coin. ATP, Sammy, you are a bio student? Sammy, are you a bio student? Jyoti, you know ATP? Okay. So you know ATP, right? ATP, adenosine triphosphate, ATP. They are like energy coins. When they get hydrolyzed to give you ADP plus PI, then delta G, which is released, of delta G for this reaction, is highly negative, highly negative. So whenever there is a non-spontaneous reaction in our biological system, then that reaction is coupled with a highly spontaneous hydrolysis of the ATP. ATP breaks down into ADP and PI. This one has a very high negative delta G. When these two reactions coupled like this, A plus ATP giving you B plus ADP plus PI. So this delta G for this reaction is negative for this one, right? So the point is clear. Coupled reactions. So what is the advantage of coupled reactions? If one reaction is non-spontaneous, other reaction is highly spontaneous, you can add these two reactions and the net reaction will be spontaneous reaction, right? Okay, I'm going to clear this. So we were doing electrochemistry. So I was discussing about the reduction potential table, then how to calculate E cell value. So all these things we did in the last class. Okay, these questions we did. Then I told you the relation between delta G, E cell and K. So are you okay with this table? So delta G is connected to K by using this equation minus RT ln K, and delta G is also connected to E naught cell. This is delta G naught, all of them. Now what is F here? Do you remember F? F is the Faraday's constant and it has a value of 96,500 coulombs. It's a constant. It is the charge on 1 mole of electrons. Charge on 1 mole of electrons. You take 1 mole of electrons multiplied by the charge on 1 mole of electron. You take the charge multiplied by Avogadro's number. You will get this answer near about. Actually, is I think 96,487, something like this. But AP generally is taking this value approximated. And what is N here? N is the number of electrons transferred, number of electrons transferred during that redox reaction. So all these things I explained yesterday. You're okay with this table? If delta G naught is negative, then K is greater than 1. E naught cell is positive. Reaction is spontaneous. Spontaneous means it favors the formation of products. Products will be more. If delta G naught is negative 0, this one is 0, then K is 1, ln K. If K is 1, ln K is 0. 0 times RT is 0. Delta G naught 0 when K is 1. E naught cell is 0. Delta G naught 0. E naught cell is 0. Reactants and products are equally formed, equal in amount. Then this one, if delta G naught is positive, K is less than 1 and E naught cell is negative. Very important table. Very, very important table. Okay, now let's see some questions based on these equations. Let's do this question. Ready? First of all, these are reduction potentials. Reduction. The values are reduction potentials. They are asking you to determine E naught cell. Look at these reduction potentials. Identify which one is anode and which one is cathode. Yes, anode is oxidation, cathode is reduction. Now look at their reduction potential values and identify which one would like to undergo reduction. One will undergo reduction, other definitely oxidation. So which one? Look at the values. Who has higher reduction potential? This one. So this reaction is reduction. One second. It's like this. VO2 plus 2 VO 2 plus. What's the oxidation number of vanadium here? Can you check the oxidation number of vanadium? Let's say X. X plus 2 times minus 2 is equal to plus 1. So what is X? Plus 5. Atharva, very good. What's the oxidation number of vanadium here? Let's say X. X plus, there is 1 oxygen, minus 2. Those who are not doing quizzes, they are confused today. This plus 3. Going from plus 5 to plus 3, oxidation, reduction. Going from plus 5 to plus 3 is reduction. How many electrons is gaining? Is it plus 3 or plus 4? This one. X plus minus 2 is plus 2. Is plus 4. Sorry, yes, plus 4, not plus 3. Okay, going from plus 5 to plus 4 is reduction. So how many electrons are gained? Plus 5 to plus 4. How many are gained? 1 electron. Then if this is reduction, this is your going to be cathode. So this is cathode. This compartment is cathode because VO2 plus is here. It's cathode. So definitely other compartment is anode, right? So the other reaction is oxidation. Cadmium solid is getting oxidized to cadmium 2 plus. So this oxidation number is 0. This is plus 2. So how many electrons? 2 electrons. This one is losing, gaining 1. This one is losing 2. If you remember the balancing of redox reactions, the number of electrons lost and gained must be same. So it means I have to multiply the above equation by 2. This we did in unit 4. The whole equation is multiplied by 2. Nowadays, I think in the schools also, they must have done unit 4. They are on unit 5 and 6. Now you can add the equations. Cancelled? What's the net equation? 2VO2 plus cadmium solid giving you 2VO2 plus cadmium 2 plus. That's the net equation, right? Okay, so this is the cathode. This is reduction. This is oxidation. So this is the anode. So how the electrons will flow? Electrons will flow from cathode to anode or anode to cathode. This we did yesterday. Cathode is where oxidation is taking place. Anode is where reduction is taking place. This is the net equation. Sanvi, I didn't give you the complete balanced equation. If you want to balance it, then water will also come there. Okay, then we have to balance it in acidic condition or basic condition. Then I'm just balancing the electrons. So I'm not balancing the oxygens, right? I know that oxygens are not balanced. So you have to add 4 oxygen here. So add 2 water over here. Then you have to add 4H plus. Now it is balanced. So I was not taking care of this. I just gave you the net equation. Yusuf. Okay, that question was from Yusuf. Yusuf, good participation. Yusuf said the equation is not balanced. Yusuf, are you okay with it now? I didn't balance the equation for oxygen and hydrogen because they are not undergoing any change. I balanced it only for vanadium and cadmium. That's it. And I didn't take care of anything else. Okay, fine. So that was a good question. Now So electrons will flow from anode to cathode. Very good, Sanvi, and very good, Semi. So electrons are flowing like this. Because these two electrons which are released over here, they will go up. They will not come in the solution. And what will come in the solution? Cadmium 2 plus. From this cadmium, solid cadmium electrode. These two electrons will travel here, and then this VO2 plus, this one will go and capture these two electrons to give you VO2 plus, the reduced species, this one, right? Okay, so now what is the E node cell? You remember the equation of the E node cell, children? E node cell. E node cell is E node cathode minus E node anode. And you are going to plug in reduction potential values. Plug in reduction potential values. Yes, very good, Sanvi. Cathode is how much? This was cathode, right? 1.00. Anode is how much? 0.40. Answer is 0.60. Unit is volts. Potential, cell potential, volts. Okay, this V. Now this is E naught cell. Now they're asking delta G naught. Now you know that delta G naught is minus NF E naught cell. You know this equation. Now what is N here? N is the number of electrons transferred. So how many electrons are transferred? Two. You can see two. These two. During this reaction, two electrons are transferred. One is losing two, other one is gaining two. So N is two. What is F? F will be given to you in the formula sheet. They will give you F. Faraday's constant. Units are coulombs. This is 2 moles because we are working with moles here. And E naught cell we calculated here. Plug in all these values. E naught cell is negative or positive? It is positive. It means reaction is अथवा spontaneous. E naught cell is positive, so reaction is spontaneous, right? So delta G will come out to be negative. Let's check that whether the delta G is coming out negative. Plug in the values. This minus is here. Then 2, then times 96,500 coulombs times E naught cell, which is 0.60. And this answer will be in joules. Everything is in standard international unit. Volt, SI unit. Moles, SI units. Coulombs, SI units. So what is the SI unit of delta G? Joules. So this answer will be in joules. So you can work out the answer. Answer should have only two significant figures. 0.60 is going to decide the sig fig. So what's the answer, Yusuf? Can you do calculation very fast? And answer is 1.2 times 10 raised to power 4 minus will be there, joules, which you can write as minus 120 kilojoules. That's the answer. And this delta G is negative means reaction is spontaneous. But now they are asking K value. So what are you expecting? K will be greater than 1 or less than 1? See, E naught cell. This can be a multiple choice question without calculation. Is it 5? Yusuf is saying it is 5, but I got 4. Children, can you check? Who is going to check this? Whether I'm right or Yusuf is right. Please help me. Yeah, he's right. It is raised to power 5. So if I multiply this, divide by 1000 to convert that into kilojoules, so it will be 1200. Highly spontaneous process, very high negative delta G, isn't it? No, 1200. So it will be 1.2 times 10 raised to power 2. No, it is 120 only. Sorry, 120, right? Answer is same. No change in the answer. Is it okay, Yusuf? Atharva, you're doing calculation? Jyoti, Sanvi, please confirm this answer. Okay, fine. Get the value of K. Now, delta G negative. E naught cell positive. So K will be greater than 1. So when you calculate K, you will see K will be greater than 1. There are two ways of calculating K. One is E cell is equal to 0.059. This equation will be given to you. Log K over N. Either you can use this equation or you can use this equation. Minus RT ln K. You want to calculate K? I can rearrange this equation. Ln K is delta G naught over RT. Plug in this value. So it is minus 120. R is 8.314. T is 298. Standard conditions. But this is kilojoules and this is joules. This answer is in kilojoules. And this will be in joules. So I have to multiply it by 1000. Now it is also in joules. Get this value. How much is this value, Yusuf? I'm teaching, I'm calculating. You people are not helping me. Sanvi, what's the answer? Is it 48.4? Yes or no? Yeah. Okay, okay. I'm getting 48.4. So let's take 48.4 here. One second. But that's the value of ln K, right? So I'm writing here because so much I've written on this whiteboard. So I'm writing here. So ln K is, after doing this calculation, is 48.4. Now you take exponential of this E. E times ln is 1. So K is E raised to power 48.4. The inverse function of ln is E. So Jyoti is giving us the value 1.1 times 10 raised to power 21. And no units. Is K equilibrium constant? Can you see this K is very big? Is greater than 1. So reaction is highly spontaneous. So this is one type of question based on the equations which we did on the previous slide. So moving on now on the next question, next concept, the effect of concentration on cell EMF. This question is without calculation, you have to understand. Remember, I spent so much time in mathematical zero unit. So there I was focusing on these things. So I don't know whether you can recall all these things, but definitely the time spent on that mathematical unit is not a waste. So let's see how to use it. Understand this concept very well, children. You remember I gave you the reduction potential values. This one, this table. Okay. Here, this table. If you look at this, these are E naught values. E naught means standard conditions. And what is the standard condition? Standard condition means, yes, any one of you? Temperature 298 Kelvin. Concentration of these 1 molar. Pressure 1 atm. That's the meaning of standard conditions. But it's very difficult to maintain the concentration 1 molar throughout the experiment. Once the reaction starts, concentration will decrease. So as the concentration decreases, what happens to E cell? This is E naught. I was calculating E naught cell by using E naught cathode minus E naught anode. But if the conditions are not standard, then this is not E naught cell, then it is E cell. How to calculate E cell for a reaction? So we are going to work on it. So that's the next concept. Please understand that concept. It's very easy but very important. And this will give you Nernst equation. Okay. The equation which you will get is Nernst equation. Again, I'm showing you how to get the equation, but AP will not be asking you how to get the equation. But it's always fun to know how we are getting this equation. Delta G naught is again under standard conditions, and there is another term delta G, non-standard conditions. There is no naught here. There is an equation that delta G is delta G naught plus RT ln Q. What is Q? If you remember this Q, reaction quotient, QSP, QA, all these things. Remember when we were learning chemical equilibrium, I was making graphs like this. This is equilibrium when the concentrations are not changing. But before that, what is this? If I take the ratio here, this is Q. Q has the same expression as K. Like if A is in equilibrium with B, what is K, children? K is concentration of B over concentration of A, product over reactant. And if let's say this is not an equilibrium, system is still struggling to come into equilibrium, then it is Q. What's the expression of Q? Same. Concentration of B over concentration of A. But Q is changing. K is constant. Q is not constant because Q is non-equilibrium state. So this Q is here. It has the same expression as K, right? But I gave you this equation also that delta G is equal to minus NF E cell. See, I'm not using naught here because delta G is also not naught. These are non-standard conditions, right? Now you plug in this here. Check delta G minus NF E cell. Delta G naught minus NF E naught cell, which you can calculate by using reduction potential table. And plus RT ln Q. Now do one thing. Divide the whole equation by minus NF. Now this minus NF cancelled. This one is also cancelled. Am I right? So how the equation will appear? these two cancelled, E cell is, these two cancelled, E naught cell. This plus will become plus and minus, minus RT over NF ln Q. This is Nernst equation, Nernst equation. This equation is used to calculate the E cell for non-standard conditions when the concentrations are not 1 molar. Check here. R 8.314. Generally, we carry out all the reaction at 298. F 96,500 coulombs. When you plug in these values in your calculator, your equation changes, and convert this ln to log. Equation changes to E naught cell minus 0.059 over n log Q. ln has become log. Check this answer, children. 8.314 times 298 divided by 96,500. To convert ln to log, I need 2.313. Can you just multiply and divide and check? Are you getting something like this? Check. This complete number should be this. Is it? So that's how they derived this number 0.059. Who is doing this calculation? Yeah, I'm getting 0.059. So if you do this calculation, use your calculator, make habit of using your calculator. You'll get this number. So this is your Nernst equation. Now we have to see the application part of this Nernst equation. Okay. So what is the Nernst equation? E cell is E naught cell minus 0.059 over n log Q. What type of questions will be there? Now understand the type of questions. Let's say this is the reaction, copper solid reacting with, okay, I'm changing this reaction. Zinc solid is reacting with copper 2 plus, giving you copper solid and zinc 2 plus. That's the reaction. These are the aqueous and these are the aqueous. Can you tell me what is the Q expression here? What is the Q expression for this reaction? Remember, solids are never the part of the K and Q. So don't take this solid. Solids concentrations are taken as unity. So what is Q expression here, children? Do not take this solid and this solid. Just take the concentration of the product to that of the reactant. So it is, yes, Yusuf, zinc 2 plus over concentration of copper 2 plus. Now let's see what type of questions will be there. Okay. If Q is greater than 1, what does it mean? If the concentration of zinc 2 plus is greater than concentration of copper 2 plus. That's the meaning. If this concentration is more than this, Q is greater than 1. Then log Q will have a positive value. Agreed? These type of questions will be there. Now, what is the importance of this positive value of log? Then you come back on this equation. Then if this log Q is positive, then this will remain negative. Then it means if log Q is positive, it means the E cell will be less than E naught cell. You're getting it? You'll be getting less potential when the concentration of the product, the one in the numerator, is more than that of the reactant. So they say that try to understand in terms of Le Chatelier principle also. If this concentration is more, then in which direction the equilibrium will go? If this concentration is more, the reaction will shift in the, yes, remember the Le Chatelier principle? The reaction will shift in the reverse direction because this is more. If it is going in the reverse direction means E cell is becoming less positive. Reaction is less spontaneous, less than what it was earlier. So children, I'm not getting any answers from you, but I hope you're understanding this. Yes, please type yes or no. Sammy, you're understanding? Okay, good. Can I ask questions? Are you clear that I'm focusing on the sign of log Q? If log Q is positive, then E cell is less than E naught cell. But if the same log Q is negative, if log Q is negative, then what happens, children? Yes, Atharva. What happens? If log Q is negative, this is negative. This is also negative. Negative, negative will become positive. Then E cell is greater than E naught cell because this is negative. This is negative. Negative, negative is positive. E cell will become greater than E naught cell. Can you tell me when E cell is equal to E naught cell? In which case? When log Q is 0. And when is log Q 0? When, understood? So is the magic of log Q clear? Okay. Writing one equation, A solid reacting with B plus aqueous, giving you B solid, A plus aqueous. The concentration of A plus is 0.1 molar. The concentration of B plus, they are in equilibrium. The concentration of B plus is 0.01 molar. E cell is E naught cell minus, what's the value? Remember the equation? 0.059 over n log Q. What is Q here, children? Q. What's the expression of Q? First, you give the expression of Q. Mhm. Look at the equation. What's the expression of Q? You're not writing expression of Q. Now, all of you, please type the expression of Q. Q is just like K. But Q is a struggling condition for equilibrium. But expression will be the same. So what is it? Q expression. Mhm. We spent so much time with Q in unit 7. Yeah, unit 7. Chemical equilibrium. Any one of you typing this? No? Okay, so the expression of Q will be, I've given you so many times, I've explained you. If you try it, then you will see that you can retain it. If you don't try, if you are just watching what I'm writing, that's not learning. Q is concentration of A plus. I'm not going to include solids that we have learned in chemical equilibrium divided by concentration of B plus. Now plug in these values. Is this Q greater than 1 or less than 1? This Q is greater than 1 or less than 1? Check. Can you do this? Is greater than 1? Yes. Then log Q will be negative or positive value. Log Q will be negative or positive. If Q is greater than 1, log Q will be any number greater than 1 when you take logarithm 0 unit, mathematical 0 unit, then log Q will be, yes, Yusuf, is, no. Q is greater than 1. Q is not 1. Q is greater than 1. Is positive. Yes, Jyoti. Is positive. If Q is positive, then E cell for this reaction will be more than E naught cell or less than E naught cell. These type of questions will be there. E cell will be, see, this is positive. This is negative. Minus plus minus. So E cell will be, yes, please. E cell will be, see this, whatever left is this only. If you are unable to answer, then it will be very difficult for me to teach. Atharva, mathematics. Is there any problem with this mathematics? This is positive. This is negative. I want to compare E cell with E naught cell. Now, which one is more, E cell or E naught cell? E cell is less than E naught cell. Why, Atharva? Children, you're not understanding this simple mathematics. Log Q is positive. So when you plug in the value here, this complete answer will be negative. So definitely E cell will be less than E naught cell because I need to subtract this value, right? Is it okay? So E cell is less than E naught cell. If I want to make, answer this question. If I want to make E cell, Sammy, you're not answering today, greater than E naught cell, what should I do? If I want to increase my E cell, because E cell is the cell potential, it is the, you want your battery to give you more potential, right? If I want to make E cell, so Yusuf is saying, make your log Q negative. How, Yusuf? How can I make my log Q negative? Yes, but how? How can I make? Make your Q less than 1. How can I make it less than 1? It means the concentration of B plus, make concentration of B plus more than that of concentration of A plus. Add more B plus. Add more and more of B plus. Reaction will go more and more in this direction, right? This will ensure that your B plus is very high, A plus is less, Q is less than 1, and that will ensure that reaction will go more in the direction of the product and you will get more cell potential. Your battery will live longer. Is it okay? You're learning batteries, children, the battery which you are using every day in your life. They all are based on this concept. Okay, answer this question. First of all, okay. First, I need the reduction potentials. Ready for the reduction potentials? Let's go to the reduction potential table here. Okay, let's go here. One equation is this. Please write down the reduction potential for this equation. 0.080. Other equation was with hydrogen peroxide, this one. 1.77. Both the values are positive. Now I'm going back on the question. Here is the question. This is 0.80 volts. This is plus 1.77 volts. Which reaction would like to undergo reduction? What is cathode here? What is anode? Mhm. Which reaction will undergo reduction? Compare their reduction potential. Which one has higher reduction potential? This one. This is cathode. And this will be anode. So anode means oxidation. So I'm writing the equation again. H2O2 plus 2H plus 2 electrons. I need to multiply this equation by 2. Sorry, not this one. The above equation by 2. Am I right? Because this one is gaining 2. So the above equation should give us 2. So this equation I'm writing as such. But the above equation is anode. So I'm writing in the reverse manner. Reverse manner, why? Because that is oxidation. So Sanvi, I'm writing oxidation. Now I'm multiplying the whole equation by 2. So it becomes, now this is 2, this is 2, this is 2. Now add the reaction. 2 electrons cancelled. Now the equation is H2O2 plus 2H plus 2 silver solid, giving you 2Ag plus 2H2O liquid. That's the equation. You must be thinking why she is writing the equation. Because they want me to compare E cell with E naught cell. It means I'm going to use the Nernst equation, that E cell is equal to E naught cell minus 0.059 over N log Q. I need to know this Q. If Q is greater than 1, if Q is less than 1, only then I can predict. And for the Q, I need to have the reaction. So what is Q expression? Now again work with me. It is the concentration of the product raised to power their coefficient, concentration of Ag plus raised to power 2. But this water is pure liquid, so don't take it. It's not the part of your Q. Divided by concentration of the reactant. Reactant is this, but solid is not the part. So concentration of H2O2 times concentration of H plus raised to power 2. All these things we did in chemical equilibrium, right? Now, what are we going to do for the A part? Get the value of Q. Plug in the concentration of Ag plus, which is 1.0 raised to power 2. Concentration of H2O2, 2.0. Concentration of H plus, 2.0 raised to power 2. So this answer, this Q, is it greater than 1 or less than 1? Check. It is 1 over 8. Q is less than 1. Q is less than 1. So what is log Q? Log Q is negative. If log Q is negative, then E cell is greater than E naught cell, isn't it? Sanvi? So I predicted. We are not answering the complete question. We are just checking. So why I needed these values will be given to you in the exam. Why I needed these values? Because only then I can decide anode and cathode. Only then I can write down the complete equation. Only then I can write down the Q expression. And then I'll plug in these values to know whether Q is greater than 1 or less than 1. And then you can answer. Predict. Don't calculate, just predict. So I predicted from the value of Q. Can you do the B part, children? I'm waiting for the answer. B part. B part is a test for you, for all of you. So just don't take much time, okay? We have to do few more things. Let's do the B part. Get the Q for the B part. Let me see who can give me the value of Q very fast. Check whether it is greater than 1 or less than 1. So you have to tell me whether it is greater than 1 or less than 1. Very good, Yusuf. It's greater than 1. Is it correct? Jyoti, Sanvi, Sammy, you're doing? Plug in the values from the B part. Okay, Jyoti is saying yes. Q is greater than 1. So we can move on. Then log Q will be negative or positive? Will be positive. Okay, log Q is positive. If log Q is positive, then E cell, if I want to compare E cell with E naught cell, E cell will be less than E naught cell or more than E naught cell? It's less than. So these type of questions. So which reaction is more good for us if I'm using a battery? Is this condition good or this condition good? Which condition is good? This condition when my E cell is more than E naught cell. This I'm getting more cell potential. This condition is good. But what is this condition? In this condition, the reactants are more. Can you see the reactants are more? These are more. And if these reactants are more, it will push the reaction in the forward direction. Lee-Chatelier principle. They ask you to explain using Lee-Chatelier principle in the free response question. This is the mathematical understanding. But you can use the Lee-Chatelier principle that when reactants are more, reactions shifts in the direction of the products. So as you are getting more and more products, you're getting more and more cell potential, more oxidation reduction, more cell potential. So for the battery, we should always have more reactants. So as the reactance decreases, battery starts dying out. You know, you say, my battery is dead, let me recharge. So when the battery is working, it's a galvanic cell. It's working on its own. But when you are recharging the battery, when the reactants are very less, products are very high, so reaction has stopped nearly, then you are recharging. When you are recharging, then it is electrolytic cell. Then it's a non-spontaneous reaction. And you are using electricity, recharging, you use electricity, right? You plug in your battery in the electrical supply. So using of electricity is electrolytic cell, right? Okay, moving on, children. I think concentration cells is not the part of your learning. I checked it. So I can leave it. Now the last topic of this unit is electrolytic cells. This I decided to leave because I was checking the topics over there, so this was not mentioned. So what is electrolytic cell? What is electrolysis? Electro means electricity. Lysis means breaking down. Like NaCl, very stable compound, very, very stable. You know, it is there in the seawater, plenty of it. You want to break it down, decomposition, to give you these gases and this solid, this one, solid, sorry, not liquid, this one. This reaction, delta G is positive. E cell is negative. K is very less than 1. Reaction is totally non-spontaneous, very non-spontaneous reaction. But we are using this reaction to get the chlorine gas. How? We are using electrical supply. We are using electricity. And we are breaking down this NaCl into Na and Cl2. So this is called as electrolysis of the NaCl. We are doing electrolysis of the NaCl. Same with water. You know, water is one of the most stable compound. It is the most abundant compound on the earth. It's very stable. So breaking down this H2O to H2 and O2 cannot be done by normal reactions because it is again non-spontaneous reaction. I'm balancing the equation. It's a non-spontaneous. Delta G is positive. E cell is negative. So again, I have to use electricity. Use electricity to carry out this reaction. So these type of reactions are called as electrolysis, or the cell in which we carry out these reactions using electricity, they are called as electrolytic cells. Electrolytic cells, right? So we did galvanic cells. Galvanic cell delta G is negative. Electrolytic cell delta G is positive, non-spontaneous. See, non-spontaneous. This is the electrolytic cell picture. See here, there is a battery. Battery means you are supplying electricity. Battery has a positive terminal and negative terminal. The positive terminal is connected to an electrode. This is the electrode. Negative terminal is connected to another electrode. The negative terminal will give electrons. They will pump in electrons. Like this, you can see how the electron is going. So definitely this negatively charged electrode, because it is connected to negative terminal of the battery, is called as cathode. It is the one who is taking electrons from the battery. The negative end is supplying electrons. But on the other hand, the positive end is asking for electrons. Can you see how the electrons are coming out? So this is anode, because electrons can come out only if oxidation is taking place. So this is the electrode where oxidation is taking place. Oxidation. That's why it is called as anode. So anode is positive charge plate. Here anode has a positive charge. And it is the one who will be asking electrons from the ions, atoms, whatever is there. And then these electrons are moving out. So electrons are flowing again from anode to cathode through this battery. You're getting it, children? Anode and cathode in electrolytic cell. Okay, now let's see what happens. We have taken NaCl molten. Molten means liquid. We have not taken NaCl aqueous. There is a big difference. Big difference. We have not taken this. We have taken this. Right? Okay, now let's see what happens. NaCl molten means there is Na plus and Cl minus. Anode is positively charged because it is connected to the positive terminal of the battery. Cathode is negatively charged because it is connected to the negative terminal of the battery. Now Cl minus will move in which direction? It will go in the direction of anode or cathode. Decide. Yes, it's a question, children. Please answer this question. Cl minus will move in which direction? In the direction of anode and cathode. You already know plus minus, how they attract and repel, right? So Sami, in which direction? In the direction of plus charged? In the direction of anode. Very good, Sanvi. Cl minus will move here. Why? What is the reason, children? Sanvi is very right. Why? Because anode has a positive charge. And why this anode is positively charged? Because it is connected to the positive charge terminal of the battery. Where this Na plus will move, Sami? Yusuf? Where the Na plus will move? These are very simple questions, so try to answer. Yes, Atharva, where Na plus will move? In the direction of the cathode. Because cathode has the negative charge. Because it is connected to the negative terminal of the battery. Right? So that's how these ions are moving. Now what happens at the anode? Anode has a positive charge. It is asking for electrons. Cl minus goes over there and it will get oxidized to Cl2, losing these two electrons. And where these electrons will go? Up here in the battery. Right? And what happens on the cathode? Na plus will go there and it will take electrons from the cathode. Cathode has negative charge. It's full of electrons. So it will take electrons and it will get reduced. And that's how the splitting of NaCl to sodium metal and chlorine gas is happening in this electrolytic cell. But they are very reactive. Na metal, very, very reactive. Cl2, very reactive. Most reactive metal, most reactive non-metal. When they are together like this, they will again combine. Immediately they will react. And that is the reason we need a very special setup. In this setup, you can see the Na, this is your cathode. So Na plus is coming here and getting trapped here, Na plus. Cathode has negative charge. And then you're getting liquid sodium here, which you are taking out. And here is your cathode, this one, center one, anode, which has a positive charge. This is anode. And Cl minus will enter here and they will get converted into Cl2 gas and you are taking them out. So they are not getting a chance to react with each other. They are in different enclosures, right? So we need a very special setup like this. But basic reaction is this only. We are good? Moving on, children, showing you another electrolysis of the water, that electrolytic cell of water. See the picture? This is a real setup. This is just for explanation. This is anode connected to positive terminal of the battery, has a positive charge. This is cathode connected to negative terminal of the battery and has a negative charge. In this, you have water, which is catalyzed or in which some amount of H2SO4 is added. H2SO4 will give you H plus. So we have H plus and we have H2O. Where the H plus will go? On the anode and cathode. Where it will go? H plus. You can see the charges. So where this H plus will go, children? On the cathode. Yes, Atharva. Here. And on the cathode, it will undergo reduction to give you hydrogen gas. So these are the bubbles of hydrogen gas, H2 gas. And where the water will go then? Water will go in the direction of anode and it will get oxidized to O2, giving these electrons, and these electrons will travel up and will go here. Sulfates are very less. We added only few drops. And sulfate SO4 2 minus, if you check the oxidation number of this sulfur, is plus 6. It cannot be oxidized. You know, sulfate will move in the direction of, tell me where it can move, sulfate. It's good that you asked this question, Atharva. Where the sulfate will move? In this direction. But on going over there, they need to undergo oxidation, right? But if you look at the sulfate and you check its oxidation number, check sulfate, sulfur oxidation number plus 6. That's the maximum oxidation number of sulfur because sulfur has only 6 valence electrons. It cannot have a oxidation number of plus 7 or plus 8. The maximum oxidation number is plus 6. So sulfate will not undergo any change. Similarly, nitrates. We take nitrates also. They also do not undergo further oxidation because they are also plus 5. Nitrogen is plus 5. That's the maximum oxidation number of nitrogen. It cannot be further oxidized. So it's very nice that you asked this question. Okay, now there is one more question related to this. That is, I'm writing the equation. H2O giving you H2 half O2. Balanced equation, right? So this is the setup. You are adding water here. Can you identify which one is anode and which one is cathode? Look at the volume of the gases. Okay, I'm showing you the volume of the gases. I'm highlighting. In one container, this is the volume of the gas. In another container, so which volume is more, yellow or green? Yellow. Yellow is more, right? So this is your H2 gas. And this is your O2 gas. Can you see the volumes are in the ratio of 1 is to half? If this is one volume, then this is exactly half of it. The ratio. These are gases. You remember Avogadro's law? You can read the volumes as the moles. You can say here the volume ratio will be 1 is to 1 by 2. Or you can say hydrogen volume will be double of that of the oxygen. So which one is anode? And which one is cathode? In water, hydrogen is plus and oxygen is minus 2. So plus will go in the direction of cathode. So it means this is cathode. And minus will go in the direction of anode. So this is anode. So this question can be there. They may ask you the ratio of the volumes. From the ratio of the volumes, you can identify the gases. From the identification of the gases, you can identify which one is cathode and which one is anode. Moving on, children. The last topic, electrolysis and the mass changes. This topic is very simple and very interesting. Very, very interesting. So learn it right now. It's very simple topic. I'm making a question to make you understand. You know the current. Current is represented by I. Its units are amperes. It is the amount of charge. Charge means Q, coulombs per unit time. How much amount of charge is flowing per unit time? So it is charge, which is in coulombs, over time, which is in seconds, right? This is one equation. So current is defined as the rate of flow of charge, how much charge is flowing per unit time. Second equation is that I can rearrange this equation. Second equation I'm talking about. I can say that the amount of charge which I'm representing as Q is I times T. So I can calculate Q. If I know the amount of the current, if I know how many amperes and the time, this is I times T. Then I can easily get the charge in coulombs. But then I know that 1 mole of electrons is 96,500 coulombs. Remember Faraday's? I know this. So I can convert my charge into number of moles of electrons by using this ratio, right? This ratio. Once I know the number of moles of electrons, I can easily get the number of moles of the substance, the one which is gaining or losing, how many moles. Once I know the moles of the substance, I can get the grams of the substance. So let's do one question based on it. Read the question. I'll help you in this question. And these are very simple questions and they're always there in the exam. They have taken molten CaCl2. So CaCl2 is converted into, this is liquid, Ca solid plus Cl2 gas. You are getting Ca solid. They have written here. Question is calculate the grams of Ca formed. That's the question. How many grams? I will calculate the grams easily if I know the moles of Ca. Now let's see the change in Ca. Ca is going from 2 plus, here it is 2 plus, right? So it's gaining how many electrons? 2 electrons to give you Ca solid. I know this equation. Now see how I'm going to do it. Okay, what is given? Amperes and time. So I will calculate Q. What is Q? Q is I times T. I is how much? 0.452 ampere and time is how much? 1.5 hours. But I have to take standard international units. So I will convert this into seconds. Now this amperes times second is nothing but coulombs. So this will give me the coulombs, the total charge which is supplied over there. So if anyone interested can help me in calculation. Answer will go up to 3 significant figures. So I can say it is 2440 coulombs. No decimal. Now I'm going to convert these coulombs. Yes, good Sanvi. Now I'm going to convert these coulombs into moles of electrons. So I will start dimensional now. From moles of electrons to moles of calcium, from moles of calcium to grams of calcium. I can do this in dimensional form. See here. 0.452 times 1.5 times 60 times 60 coulombs, which we calculated, times 1 mole of electron over 96,500 coulombs. You know this ratio already? Faraday. Charge on 1 mole of electron is this much, 1 Faraday. Times, I'll go from moles of electrons to moles of calcium. So take this ratio. To get 1 mole of calcium, how many moles of electrons are there? 2. This ratio. So plug in that ratio. What do you want? Moles of calcium. Take it in the numerator. Moles of calcium over 2 moles of electrons. And then convert that into grams. For the gram, I need to look at the periodic table. So I know that 40 grams of calcium is 1 mole of calcium. Can you see this? Coulombs, units, coulomb cancelled. Mole of electron, moles of calcium. This is 1. So the answer is, this was 2440 times 1 times 1 times this 40 over 96,500. This 2 is also here in the denominator. Grams of calcium. That's the answer. Our answer will go again for 3 significant figures. Children, are you getting this? So what you are going to do? Whatever information is given to you here, I and T, you get the Q, convert Q to moles of electrons, convert moles of electrons to moles of calcium, convert moles of calcium to grams of calcium. Yes, Q is the charge, coulombs. So, yes, Atharva? So I didn't take it in grams, I converted it in grams. Where did I take coulombs as grams? Where? I converted coulombs into moles of electrons and then moles of electrons to moles of calcium. I converted moles of calcium to grams by using this dimensional. So first you calculate Q, convert Q to moles of electrons, convert moles of electrons to moles of calcium, then moles of calcium to grams of calcium. Yes, yes. They will give you 96,500 coulombs is 1 mole of electron. They will give you this in the exam, in the formula sheet. That will be given to you. Can we do one more question based on this? Jyoti, is it clear? Can you help me in the next question? Children, you're not helping me because you're not asking question, then you're not answering at the right time. So I'm not sure how much you're understanding. Let's do this. Okay, now participate. Whether you have understood the previous one, it doesn't matter. You start participating and you will see, you will understand. How long will it take? Means time. They're asking time to plate out each of the following. Each of the following means first part. And the current is given to us. Now, how much time will be needed to take out 1 kg of aluminum? from aluminum 3 plus solution. So first you write down the reaction. Al 3 plus gaining how many electrons? 3 electrons, giving you Al solid, right? How much aluminum you want? 1 kg. So 1.0 kg of aluminum. But you want to calculate time. And I know that I is equal to Q over T. I know this equation, charge over time. So what is time from this equation? Q over I. If I know Q, I is given 100. If I know Q, I is given, I can calculate time. I will do that. How? I'll take this 1 kg of aluminum and we'll convert this into, any one of you, grams of aluminum, then to moles of aluminum, then to moles of moles of electrons using this ratio 1 is to 3 moles of electrons, then to charge, coulombs, and then I'll divide this charge by I and I'll get time. This should be the planning. Ready, Jyoti? Let's do it. Sanvi? So let's start with 1 kg of aluminum. Keep helping me, whatever you can do. Convert that into grams. Convert that into moles. Use the periodic table. I'm using the periodic table now. Convert that into moles of electrons. Now I'm looking at the equation. 1 mole of aluminum I'm getting from 3 moles of electrons. So I'll take this 3 moles of electrons in the numerator because I want moles of electrons. 3 moles of electrons over 1 mole of aluminum. Now convert that into charge. I know that 96,500 coulombs is 1 mole of electron. That will be given to you in the exam. So I plug in this 96,500 coulombs in the numerator and 1 mole of electron in the denominator. But I'm asking for time. So I'll divide this complete answer with 100 amperes. 100 amperes given. See here is given 100 amperes. And now when I do all the cancellation of the units, kg, grams, mole, I'm left with coulombs over ampere. But coulombs over ampere is time in seconds. This answer is in seconds. Everything is in SI unit. Now just put all the numbers together. 1.0. Give me 1 second. 1.0 times 1000 times 1 times 3 times 96,500. Then again this 1 divided by 1 times 27. I'm even including 1 just to tell you that just pick up every number so that you should not miss out any number. Then these numbers should be in parentheses. Now whatever answer you will get, put that answer in how many sig fig? This number has 4. See, current has 4 sig fig, but this number has only 2. This one, 2. So my answer should be in 2 significant figures, right? So get the answer in 2 significant figures. And unit will be seconds. Is this question clear, children? Atharva is saying 30 hours. But how many sig in your answer, Atharva? Only one? Because you didn't place any decimal. Is Atharva right? It's 30 hours? He was getting a very big number, so that's why he decided to convert that into hours. So he's right. You can put your answer in hours, in days also. So divide it by 60, then again 60, and he's right. 29.8. 29.8, then if you put it in 2 sig fig, it becomes 30. After 30, put a decimal. Yeah, Jyoti, but it's better to convert this into hours, right? You can leave like this also. You can leave your answer in hours or in seconds. Can we do this one, children? Ready? First, write the equation. What's the equation? That nickel 2 plus this one gaining 2 electrons. That I decided because it is 2 plus. So it will gain 2 electrons to give you nickel solid. Right? This is the equation. Then how much grams of nickel is given? 1.0 grams of nickel. From here, where are you going to go? Because you want to calculate time again. So again, you are working in the direction of time, which is Q over I. I is given to us. Q I want to calculate. From grams of nickels, where are you going to go? Yes? Mm-hmm. 2 moles of nickel. From no moles of nickel to moles of electrons. Sammy, you're not answering. Moles of electrons to charge, amount of charge, coulombs, then to time. You'll divide this charge by I. This I, the current. You get the time in seconds because we are using all SI units. Is it okay? Ready? So 1.0 grams of nickel. Take out your periodic table and give me the atomic mass of nickel. I also have a periodic table on my table. I hope you also have that. And if you look at the nickel, don't Google it, okay? Because in the exam, there is no Google search. In the exam, you will be searching in the periodic table. So make it a habit of searching in the periodic table. It is 58.69. So I will plug in 58.69 grams here of nickel. In the numerator, I'll take 1 mole of nickel. I reached up to here. Now I will look at the balanced equation. I want moles of electrons, so there are 2 moles of electrons for 1 mole of nickel. So I'll plug in this ratio. 2 moles of electrons over 1 mole of nickel. So I reached up to here. Then I know that 96,500 coulombs is 1 mole of electrons. I reached up to charge. Now I have to divide it by the current. Current is given to me 100.0 ampere. and then I will get time in seconds. Cancel the units. And you can see that you are left with coulombs over ampere. And coulombs over ampere is nothing but time in seconds. Now, just collect your numbers in the numerator. Take care, this number has two significant figures. Final answer should have two significant figures. 58.69 in the denominator and 100 also. These ones are also there. These two ones are also. So pick up every number so that by mistake you should not leave any number. And put your answer in two significant figures. Answer will be in seconds, and if it is a big answer, you can convert that into minutes or hours, even days also. Generally, hours, minutes are okay. So are we clear about this B part? So these are the questions which are based on electrolytic cells. Here they will be asking you to calculate the amount of the current. They can ask you anything. This equation that A current is Q over T. So they may ask you to calculate Q. They may ask you to calculate T. They may ask you to calculate A. They may ask you to calculate the grams of the substance. So question can be formed in different ways. Is it okay? Last question, children. This one. So the first step, Ag plus, undergoing reduction to give Ag solid. 1 mole of electron is giving you 1 mole of silver. They have given us 5.0 moles of Ag. You want this much moles of Ag. Then you can convert this into moles of electrons. Then you can convert this into charge. Then you can divide this charge by current. And that will give you time in seconds. Plug in all the values. 5.0, two significant figures again. Moles of silver. Now what is this ratio? 1 mole of silver. Oh, it should go in the denominator, right? So I'll write 1 mole of electron over 1 mole of silver. Then charge 96,500 coulombs over 1 mole of electron. Then current given 100.0 amperes, and you will get the time. Units cancelled, and you're left with coulombs over ampere. Coulombs over ampere is time. And this answer will be in seconds, right? Which you can convert in hours or minutes, whatever we want to represent. But answer should be in two significant figures because the measured amount is in two significant figures. You are going to consider only the measured amount. Measured means the one which is mentioned in the question. You are not going to use any other number as sig fig. So for the sig fig here in this question, I will consider this 5.0, this number, and I will consider this also. That is also given to me. Now this is 4 sig fig. This is 2 sig fig. So final answer should be in 2 sig fig, right? So children, this was the unit 9, which is based on your electrolytic cells, galvanic cells, spontaneity of the reaction. So I'm going to end the class now, and now your classes will stop. But my request is stay connected to me. I have a forum. You already know the forum. You know this, children? Forum? You can put plenty of questions, as many questions you want there. I think I created your accounts there. Your login ID and password is the same. Here is the link. Start doing your quizzes and do as many questions as you can. Videos will be uploaded over there. But yes, going through the video will be very huge work because there are so many hours which we have spent together. I will be very happy to help you in your preparation for AP exam. So don't think that because the classes are over, so you cannot contact me. You can contact me. Okay. And if you have any problem with any of the topic, I have two more groups going on. So if let's say this topic is not very clear, then you can always request me to add you in some other group where this topic is going on. I'll put you there. You join there. Okay. But you can, my request is now you start asking specific questions from me. Put the questions on the forum. This question is not clear. And even a simple question, tough question, 10 questions, 20 questions, 30 questions, as many questions as you want. But remember, I will answer your questions in your midnight because at that time I'm free. In your evenings, I'm not free. Give me 1 second. So, all the best, do well, and Happy New Year.